So thank you for the introduction. I'm back once again this year to present to you the RobinHood V4 progress report. And let's start into it. So first a reminder about the goal of RobinHood overall. It aims to provide efficient and easy to use means to replicate and query any storage system metadata. These storage systems include mainly the file systems like cluster, but can now also include object stores or databases. How it works, as of last year, after the presentation I made last year, it was based around a core library called RobinHood in the sidechain. This core library interacts with several backends. So at the time we had only 3, which were the Lustre and the POSIX file system as a read-only backend, and the Mongo database as a read and write backend. On top of this core library are different tools that modify the behavior of the core library to interact with the backends. So we have RBH sync that will copy the metadata from a storage backend like Lustre to another backend, mainly here Mongo. We have RBH find to query said storage replica with special filters and return a series of entries. We had RBH X find, which are overloads of RBH find specifically targeted towards different backends, because those backends provide different information that we need to query in a different manner from the base RBH find tool. And finally, we had the RBH FS events, which is to update backend, a storage replica, with additional information retrieved from the main backend. So the main usage we have for RBH FS events is with the Lustre chain logs to update the database and keep it updated. And that's it. So what did we do during last year? So I apologize for the pixelated pictures, unfortunately. We did a lot of things, actually. First, on RobinHood, we have improved the error skipping we do in RobinHood. Before, the default behavior was to, when we had any issue during the run of an update or a read of the file system, we would instantly stop the tool which runs the command, which is an issue because when we have, for instance, an entry-related error, for instance, a stat that fails, it can be only this entry that is problematic, and we can continue the scan. So we changed the default behavior to instead skip all entries-related errors, but keep the failure on program-related errors, such as memory issues. To default back to the old behavior, we added this small option, the no skip flag, to say if there is an error, whether it's entry-related or not, we instantly stop the program. Next, we'll see added the configuration of the tool. This is done either through a configuration file or environment variables. And we can, with this, we can manage currently a few things, mainly, for instance, the MongoDB address, so where the database is stored, so that we can target distant databases that are not on the same node. And also, for instance, here, the types of the extended attributes. This is done with this map that will map a name of an attribute to its type. Also, and the main points for the new the updates on RobinHood, we have a lot of new backends. So first, the STR backend is completed. It was part of the IOC European project, and it's an object store that is used in the project. And mainly, we have the MPI file utils backends. This can be used on top of POSIX and Lustre, and simply aims to improve the performance of RobinHood by using multiple clients on multiple nodes. And finally, we have the MPI file backends, which the goal of is to use MPI file utils tools with RobinHood, like dwalk and define. So I've put here the different example of those backends. The first line is the STR backend. You can see then the different MPI backends using MPI run to work properly. And the last line, this line here, is the sync to MPI file backend. And then we can use that file in the next line, the MPI run, to do, for instance, a defined on this file and output to a certain output file. On other tools, so first IBH find, we added the first printf action, which is used to print additional information about entries and customize the output of the command. And alongside it, we added also the exec and delete actions to execute a piece of code on the found entries and delete to remove completely from the system either the entries or the objects, depending on the backend used. On the overload we had for Lustre, so IBH find, we added new filters. So this one, for instance, the pool name or the strike count, and also better handling of the retention attribute with printf, which is the printf developed for IBH find. So for the retention attribute, we can now print the attribute set by the user. I will talk a bit more about the retention attribute just in a bit. And also the expiration date that is computed by RobinHood. So for instance, you can see in the code below, we have the printf, and we then print the path, the attribute set by the user, and the expiration date all in one line. For IBH events, the tool is mostly completed. We have the deduplication process that will prevent unnecessary interaction with the mirror system. And so, for instance, if you have a create of an inode and then immediately it's removal, there's no need to interact with the database, as the inode does not need to be recorded, as it will be removed instantly. So for this, we added an additional parameter for the number of entries to keep in memory. So here it's the IBH event batch size parameter, which is set, for instance, here at 500. That means we will keep 500 entries in the memory before deduplicating, before flashing them to the backend. We also have the acknowledgement of entries. So for instance, since for Lustre, when we manage changelog, we also have to acknowledge it and say to Lustre, we manage it, you can remove it from the records. This is done with the ACK user equals CL4, because we need to provide the client that requested the changelog reading. And then we also have the changelog dumping linked to it, which aims to keep a permanent record of the changelogs by keeping them on a separate file, for instance. Here we have provided the option below. We can see the --dump at the start of the command, which will output this one to stdout. This is an example of the output. It is the exact same output as RobinHood 3, and it will provide the exact same information. Now we also created new tools for RobinHood and centered around the RobinHood. The first one is IBH capabilities, which is a tool mainly to ease the use of RobinHood 4 by providing two things. The first is the ability to get the list of installed backends. This is done with the -- list, and we list all installed backends in the standard library path that we have on the system. So for instance, here you can see we have Mongo, PostGIS, and or Lustre. And the second part of this tool is to get the capabilities of certain backend. So here, for instance, we get the capabilities of Mongo, which means we will know how the backend can be used in relation to the different tools. So it can be used as a source, for instance, for IBH sync, as a source for the filtering, and such things. So the retention, it's been a big part of the last year works. First, a small reminder, our issues we had when we developed this feature is mostly that users do not want to archive their files or delete them. They want to keep them as long as possible, especially the old and unused ones, which is kind of annoying because it fills up the hosties and it takes a lot of space to keep them forever. So we, to compromise and manage this for them, we developed the retention, and we do it through an extended attribute. So it can either be set by the user, or for instance, it can be automatically set by different programs that generate a lot of files. So for instance, if you do an experiment, you can simply have in the base program, all the output will have a retention attribute automatically set at the end of that program. So we had to modify a lot of different tools to make this properly work. The first one being RobinHood. In the last year, we created the base functioning, which is we have an attribute on a specific file, and if that file expires in relation to the attribute, we can then delete it or simply output it for archival or anything. This is very annoying for a lot of users, because when they generate a lot of inodes, if they generate 1 million files, for instance, in an hour, it's extremely annoying to set one attribute on 1 million files. It's impossible to do. So to ease this process, we added the same behavior for directories. So now the retention attribute can be set on directories, and it will apply to the whole tree of that directory. This attribute can be changed in the configuration. So for instance, we have here the retention exeter is set to user.expires, and it can be changed at will. I've shown here an example of the value of the attribute. So it's get f at tier. If it's plus 42, it means that the file expires 42 seconds after its last usage. So it's by last usage, I mean the access time or the modification time. So 42 seconds after its last usage, it will be considered expired, and then we can do whatever we want with it, maybe archive it, maybe delete it. For this also, for the retention feature, we created a new tool called RBH Update Retention, which is specifically targeted towards directories. It will check if a directory is truly expired. I will explain that in the next slide. But if it's not, we update its expiration date. But if it is, we consider it to be thus expired, and then we can archive, delete, or print it for different purposes. So how it works for directories, the retention of directories, it follows this simple graph. When we check a directory to know if it is expired, we retrieve the 3 parameters for this calculation: the modification time of the directory, its retention attribute as set by the user, and the expiration date as computed by RobinHood. The first question we ask simply ourselves is the directory expired? If it isn't, we simply exit the program because we have nothing to do. But if it is, we'll do an additional step, which is traverse the whole directory to find the most recently accessed file in it. So the file which has the most recent either access time or modification time. And then we do the calculation, which is we take the file's access time and the retention attribute of the directory, add the two, and check if it is greater than the expiration date of the directory. If it is, that means we can change the directory's expiration date, because we have accessed a file in that directory more recently than the expiration date that was set on the directory. So we can push back the expiration date of the directory. And then we can exit the program, and we'll come back later to check if that directory is expired again. If the calculation means that the expiration date is larger than the access time and retention attribute, that means even with this calculation, the directory is still considered expired. So we consider the directory to be truly expired, as in a sense, and then we can do whatever we want with it. For instance, remove it. I've given you an example of how it works. So we have the tool called on database, and we have to give it the mount point of the file system that is recorded, because if we want to delete it, we need to know where to delete it. So if you can see here, we have, for instance, the directory 1, which expiration date is set to this date here. The last access file in it is 1 second later. And then, since we made it so that the directory expires 10 seconds after its last usage, we see that since we access the file more recently than the expiration date of the directory, we'll set the expiration date of the directory to 10 seconds after the last access file, +1 simply for to prevent issues with falling on the exact same second and things like that. And on the other hand, for instance, we have the directory 3 expiration date here, which is this one. But since it is empty, there is nothing to check inside, so we can skip it. So this is a current RobinHood architecture as of today. We have 5 backends, which are the str object store, which is read-only, the MPI file, which is read-write, the Mongo database read-write also. And finally, we have the POSIX and Nestor backends, which are read-only, but can be accessed by either MPI file utils, which is the common way we have now, or FTS, which is the old way of doing so. On top of it, we still have the old tools, ABS-Sync, FS-Event, Find, Xfind, and the two new ones, capabilities and update retention. So we then wanted to check with the MPI file utils backends if it was worth it to add them and the performance improvements we had on the tool. The main goal was to meet our own performance requirements, and you can see we did a number of benchmarks with 4 entities, but a varying number of clients, inodes, and processes. All of these tests have been done on a virtual machine, not on an actual hardware. But the main point to see, is that for 2 million inodes, we can go up to more than 30,000 entries per second, depending on the number of processes and nodes. And overall, the key point is that RobinHood 4 is scalable, and it works well in a multi-node and multi-client setup. So it meets the requirements we wanted for the tools, and we can we will have then to improve it. But we also wanted to check these results on actual hardware. So we checked in on a 250 million inodes system with 4 NDT, all of these specifications, and we check mainly 2 things first. The first being the database weight. So for RobinHood 4, we are more than 3 times as lightweight as RobinHood 3, and we are at least better than RobinHood 3 on the best setup we could muster for this test. So we also hope to be able to improve these performances in the future, and in a better setup, and also when we have more nodes and more processes available. So in short, for this whole presentation, the key main points to take away are the additions of the MPI file utils backends to improve the performance of RobinHood overall, the configuration file to configure RobinHood, for instance, the database address. More specifications will be added in the future. We have the retention feature, which is by and large complete for our needs and for the different tests we've done, and FS events, which is also mostly done. So RobinHood 4, the first version of RobinHood 4 is out, if you want to download it. We've done pre-production tests on our systems, mainly specifically targeted for the retention feature, which were conclusive in that the retention feature works for the needs we have, and it works in considerable, a pretty good amount of time, which was one of the main points of the tests. So what's next for the tool, for ABH4? We have the ABH report tool, which will be coming before the end of the year. It's the main thing we have to work on. We have to do database improvements, so mainly for sharding or configurable index. Performance improvements of the different tool, mainly through the use of multi-threading. And then not on the side, but less important, are different backends. So, for instance, SQLite for usage by regular users, because currently RobinHood 4 is only usable by admins. But for instance, some users requested for us that they'd be able to synchronize their directories and their homes to check how they use their own quotas. So this is the goal of the SQLite backend. We have the Phobos backend for cold storage management, an SEO Linux backend which will be built on top of Lustre, and we aim to deploy the tools on our system during 2024 and 2025. Finally, last slide. It's an open source project, so if you want to help with development, the tool suite is on GitHub at this address. All the reviews are done on GitHub. And for instance, I've put here an example of a patch that is currently in review, which aims to update the different tests. We have our test suite for the new version of Linux, OpenMPI, and Lustre. We also have, just after this one, patches to update for new versions of Mongo available for review. So feel free to install the suite overall, and if you want to test it yourself, we will be happy to receive any feedback you have. Thank you for your attention. If you have any question, I'd be happy to answer.
Thank you for your presentation. There was a retention policy,
yes.
And you're marking or saying that at least that there are seconds. So if I have a 90 days retention policy for directory, it gets really hard to figure out 7 million, 7 something. So have you considered adding some?
Yeah, we've considered it. We know for our test we only did in seconds just to validate the feature, but we add the ability to set hours, days, or even years if needed.
Okay, and the second ones that you were saying about those events, so there was a batch size about 500. How do you define the batch size? Is based on available memory of running node or?
Currently, we have we set this to 500. We don't have any really indication about what's the right batch size. I think it's mainly dependent on the system, the changelog. If there are a lot of entries in the changelogs that target the same files, it may be a good idea to keep it lower. If there are a lot of files that are touched, maybe having it larger would be better.
So first you will start with 500 and see if it works, and if you are brave enough, bigger. Thank you.
Depends on this.
Thank you. Other question?
So is the RBH find something that could be used for cleaning up files that are unused? I'm currently using Lipe find to find unused files, but then because certain subdirectories on our file system shouldn't be cleaned up automatically, we then need to resolve all of those file IDs to paths and so on. So I'm wondering if the RBH find could you do something similar but filter for paths, like everything under /scratch can be deleted if it's not accessed within 6 months or something.
So one a feature, especially for RBH find needed, is the ability to target specific directories in a database. So this is done with what we call the branching. So for instance, here we target the whole test database, but you can set it so that it targets a specific part in this database. So then, for instance, for what you ask, you can say it simply to target a different special tree in that database, and then target all the entries that are expired. This is done with the -expired filter, which is already implemented. So it will show you all the files that are expired in a specific directory in the database.
So could I then put a default expiration date on all of the files and directories that are created? So users wouldn't need to do it themselves, but I as an administrator could say that, okay, expiration date is at least 6 months into the future.
You can do it. I think with the -exec command action, sorry, you can then set the attribute on those entries, and then once again, when you do an additional, you have to then sync the entries back, because the RobinHood at that point doesn't know that you added this attribute. But then after syncing, if you ask the RobinHood to give you the expired files on those directories, it will take into account the action you've just done. Sorry.
So have you used this retention feature to do like large-scale cleanups? Have you tested what the performance of it is on a real-scale file system?
Currently, no. We've done mostly pre-production tests on a small number of users, but we want to deploy it. It's one of the next things we have to do. Deploy it on a larger scale. For instance, I think for something like 300 million entries, I note, if I recall correctly. It's one of the next thing we have to try, yes.
Okay, thank you.